Semiconductors are everywhere. Since ushering in the digital world over the last 5 decades, tiny crystalline structures have had a major impact on our daily lives, to the extent that it is difficult to imagine a world without them. Yet, until the recent shortages where demand has outstripped supply, many people were unaware of what semiconductors are and what they do, although we now know that there is a long waiting list for new cars and consumer electronics because of the shortage. It may come as a surprise to learn that the United Kingdom is home to a community of world-leading semiconductor organizations that design and manufacture the essential high-tech components that make today's and tomorrow's technologies work. My name is Chris Meadows from CS Connected, representing the compound semiconductor community based in and around South Wales. In the next few minutes, I will explain how growth applies to the world of semiconductors on many levels, from crystal growth to economic growth. Whatever people call them, semiconductors, integrated circuits or ICs, microchips or computer chips, they have been in the news for the last couple of years because of global shortages. The causes of these shortages are complex and relate to a combination of the global pandemic, trade conflicts between nations, and complicated global supply chains. There is sometimes a perception that technology is all about software and apps, but without hardware, the physical products that run the software, none of today's technologies could exist. Semiconductor products designed and made in the United Kingdom touch every part of our daily lives, including lighting, energy, enabling net zero applications, aircraft and space, healthcare technologies, robotics and artificial intelligence, mobility, transportation, vehicles, and, of course, communications. Although semiconductors are everywhere, I will use as an example the smartphones that are all familiar devices. If you were to look inside your smartphone, what you will see is lots of these computer chips that make all forms of technologies work. Inside every electronic gadget, you will find something that looks a little like this. All chips contain highly complex semiconductors that are at the very heart of all of today's technologies. But what is a semiconductor chip? The first commercial chips, made in the 1970s by companies like IBM and Intel, represented a major breakthrough by integrating around 2,000 miniature transistors onto a single chip. If you could look inside these chips, you'd be amazed at what you can see. Today's complex chips contain up to 30 billion transistors, all working together in perfect harmony. Each chip looks like a miniature city, just like this on the left-hand side. And it's just as complex as a city, but where every single part and element of that city has to work in perfect order and in miniature, something the size of a fingernail. Almost invisible under normal optical microscopes, these transistors are interconnected by multiple layers of different materials. On the right-hand side, you can see a scanning electron microscope image which shows the features of these structures. And the people behind the design and production of these chips utilize the principles you will be familiar with from studies in subjects such as physics, maths, and chemistry to make it all work to give us the gadgets we all use today and will use into the future. So, if you've ever questioned how useful the science you learn about will be, think again, because subjects such as physics, maths, and chemistry are essential in bringing us existing and new technologies. The periodic table groups elements in terms of common properties. At one end of the table we have the metals that are good conductors of electricity. At the other end, the materials are very poor conductors. The materials in the middle of the table tend to exhibit properties where they can act as either conductors or non-conductors. This makes the materials ideal for representing digits, ones and zeros, by switching between conducting and non-conducting states. And that's where the term semiconductors come from. Most computer chips over the last 50 years are made from silicon. The element silicon is used because of its unique semiconductor properties, and it is relatively abundant. It's basically sand. The UK has established a world-leading capability in the design of silicon chips, but we no longer manufacture silicon chips. Production takes place overseas. In the first few decades of computer chip development, California's Silicon Valley was home to many global companies. Today, Asia is the main source of silicon chip production. But here in the UK, we lead the way in atomically engineered products for next generation of high-performance technologies using combinations of elements, including silicon, but also germanium, aluminium, gallium, indium, nitrogen, phosphorus, and antimony. These advanced semiconductor materials are known as compound semiconductors because they comprise two or more elements combined normally within a single crystal structure. The compound semiconductor industry has grown over the last few decades as greater and greater performance is needed from devices such as smartphones, healthcare, and other technologies. As a single element, silicon has a limited set of properties. On the other hand, compound semiconductors operate at speeds that are hundreds of times faster than silicon. Typical compound semiconductors include gallium nitride, gallium arsenide, and indium phosphide-based materials. These advanced materials also offer a range of other advantages, including the ability to detect and emit light across the visible, infrared, and ultraviolet parts of the electromagnetic spectrum. Compound semiconductors are also radiation hard, which means they are more suitable for space applications and resistance to electromagnetic surges. Today, the compound semiconductor industry represents around 10% of the total 500 billion a year semiconductor sector. And it may come as a surprise to learn that semiconductors represent the world's fourth largest industry sector behind oil production, car manufacturing, and oil refining. When considering how young our semiconductor sector is compared to other sectors, its impact on the global economic growth is beyond doubt. And economic growth is not the only growth factor. All semiconductor devices start life through a crystal growth process. The first step in producing semiconductor materials is to start with a molten mass of high-purity materials, into which a seed crystal is inserted. Under precisely controlled conditions, the seed crystal is slowly extracted whilst rotating from the melt. The process can take several hours or even days. The result is the growth of a pure crystalline structure known as an ingot. Following the ingot growth process, the crystal is cut or sawn to produce individual wafers that are then highly polished to produce high-quality, pure crystalline substrates, onto which other crystalline elements are then grown to produce specific electrical and optical properties. An example is the epitaxial growth process that extends the atomic structure of the substrate and allows substitution of elements to achieve the required device properties. Some of the products are engineered at the atomic level, with just a few layers of different atoms to give the material its special electronic and optical properties. The combination of electronics and optical properties is known as photonics. The word epitaxy is derived from the Greek words epi and taxis, meaning on a common surface axis. For example, a gallium arsenide substrate comprising alternating gallium and arsenic atoms may be extended with a few atomic layers where a gallium atom will attach itself to an arsenic atom at the surface, and likewise an arsenic atom will attach itself to a gallium atom at the surface. For the next layer, aluminium atoms may be introduced to provide specific optical characteristics. Such structures may be used in applications such as 3D sensing for face recognition and to allow driverless cars to see. The proportion of aluminium, gallium, and arsenic atoms can be adjusted to produce materials that are sensitive to or can emit light ranging from the red part of the spectrum to the infrared part of the electromagnetic spectrum. Other material combinations are used for other wavelengths or colors. The production of the crystal ingot through to the wafer with its epitaxial layers is close to the start of the whole process of producing chips. The next stage is called fabrication, which involves deposition and etching of many layers of conducting and non-conducting materials to form tiny components and electronic circuits into and onto the surface of the substrate. This wafer fabrication process is carried out in high-tech cleanrooms, often known as wafer fabs. Effectively, these microcircuits are printed onto the wafer. The next step is to separate or dice the chips from the wafer and mount them into packages. This allows them to be connected into full circuit assemblies that then power the gadgets and devices with which we are all familiar. Going back to the phone as one of many examples of a gadget or device that is packed with semiconductor technology, you will find many different parts inside the device that contain semiconductors. I don't recommend taking your phone apart, or anyone else's for that matter, but if you did, you would find many different components inside. Semiconductors handle everything from managing power consumption to processing and storing data. The communications chips are responsible for connecting to the outside world through Wi-Fi and cellular data, whilst there are multiple semiconductor sensors from cameras to miniature accelerometers that detect which way the phone is, each part playing a crucial role that make our apps work. Looking a little deeper into the components that make up even just one element of your phone, such as the camera, you will find complex assemblies that contain semiconductor materials that all started life as a single crystal. Many of these sensing components are designed and produced in the United Kingdom. As mentioned earlier, silicon technologies are essential to the digital revolution, but compound semiconductors are used wherever gadgets need to generate or conserve energy, operate at high speeds, often hundreds of times faster than silicon technologies, or emit and receive light from across the electromagnetic spectrum, from ultraviolet to visible to infrared wavelengths. And although I've focused on smartphones as a key example of a device that could not exist without semiconductors, the unique properties of compound semiconductors enable a range of new and emerging technologies involving healthcare technologies, gaming, energy, transportation and mobility, and space and security systems. Without compound semiconductors, there would be no internet, not to mention a wide range of new and emerging technologies, including our ability to meet global net zero targets. In terms of economic growth, as we have seen from the impact of the semiconductor shortages, so many global markets are wholly dependent on this crystal growth technology, from handsets to gaming devices, personal computers to data centers, and industrial and consumer products, and of course, automotive, transportation, and communications. And whilst the global silicon market is concentrated in Taiwan, Korea, and China, the United Kingdom has a unique capability set in compound semiconductors for next-generation technologies. And the CS Connectors semiconductor community in Wales is home to a globally recognized world-class cluster of high-tech semiconductor organizations from Cardiff and Swansea universities, the Compound Semiconductor Applications Catapult, the Compound Semiconductor Centre, IQE, Newport Wafer Fab and Nexperia, Microchip and SPTS, Rockley Photonics and Microlink Devices. And we expect more organizations to be attracted to the region over the coming years. So I hope this has given you a flavour of why growth, both in terms of economic impact, but also in scientific terms, crystal growth, has a huge impact on everything that we do in today's society. And be sure to visit us at csconnected.com. Thank you.